forces are everywhere, right? So when you shoot a basketball, the basketball wants to travel back towards the middle of the earth.
Wants
Okay.
someone to net.
What's that?
You know, if it's still shooting.
Okay, so we're talking about one law of motion, which is Newton's first law of motion. Newton's first law says an object will remain in a state of rest unless it is compelled to change by the action of an outside force. And I'm just going to do one more little note, then we're going to do examples of the whole rest of the period. Okay? Yeah.
I was just going to ask, are you particular about the wording of the law? So if
No.
you haven't memorized
If you haven't memorized, definitely that's okay. Yeah, that's okay. I don't think, to be honest, I think I'm just doing word problems on this test. I don't think I'm going to say state of equilibrium and all that stuff. It's okay. I'll leave it like that. So we're going to say generally several forces act on an object at once. The sum of all the forces is called the net force. Since all forces are vectors, the single resultant force I'll get out of the way here soon, can be found by vector addition. If there is no acceleration, the forces are in equilibrium. Okay, let me get out of the way. Okay, so if I stand right like this, I'm not moving, there's no acceleration on me, the net force on me is actually equal to 0. Now, there are millions of forces acting on me right now. The main one is gravity and gravity and the normal pushing me upwards. There's also a force on me right now acting on Jupiter. Jupiter is pulling me slowly towards it. The sun is pulling on me. There's many forces actually working on me, but most of them compared to the Earth is negligible. Okay? So what the main thing I want you to know here from this is you can add forces together using vector addition, and it's called the net force. And the single result will be the acceleration. A lot of the questions in this unit will have equilibrium, meaning that they should all add to be 0. Okay, it's meaning that if you're dealing with horizontal and vertical components, they should add to 0 for that. Okay? I'm sorry for the big long note. The rest of today is all examples. All right, Brad, you're going to start with example 1, and example 2, and example 3, and example 4. Where's Tyler and stop? Caleb, did you give an answer?
Yeah.
So we're starting right here, I think. Right. Okay, example 1 says, Brad and Callan. By the way, I should just tell one joke. The internet doesn't need to hear this, but one of the students in my class was mad that he didn't get his name in to my example, so he just always put his name in. So it'd be like Caleb and Caleb, you know, he'd always put his name no matter what the person was, so it wasn't Caleb, it was somebody else. Anyway, Brad and Calvin are pulling Teresa on a toboggan. Each is exerting a force of 60 newtons. We're going to say Brad pulls at an angle of 30 degrees to the horizontal. Callan pulls at negative 20 degrees to the horizontal. What is the net force? What is the resultant force? Exerted on Teresa's toboggan. And I think next year what I'm going to do is I'm going to type this out for you guys. Is what I'm going to do next year, so you don't forget all this stuff. That's right. The nice thing about word problems is that they're wordy, so it'll take you a lot to write down. The nice thing about a test, though, is that all this stuff is written out for you. Okay? So again, all we're saying is it's going to be, the people are going to be pulling these things horizontally. Now, in the real life, there'd be vertical pulling too, right? Like, so in this case, we're assuming that Brad and Callan are both pulling from the ground, like they're pulling with their toes. Okay, so there's no vertical thing going on here too. It's all going to be sort of horizontal. We'll get to the 3D things in a minute. Okay. All right. So what is the first thing to do when you see a problem like this? Instantly. This will go for anybody. I'm going to pick on you in a second, Teresa. What's the first thing for a vector problem you have to do in order to get full marks on your question? Derek.
Well, I would sketch it first.
Yes. You have to show. You have to draw a picture for this. You have to. You have to. You have to. You have to.
For the question we signed.
Yeah, that one you didn't. That's fine because that was just the U and the V one. Is that all that was? Okay. So on the word problem ones, I want to see things that are. I want to see them sketched out, especially for the complicated ones here. So here we go. We're going to go to the diagram's going to be here. So here's. Whoops. All right. Okay. Okay. So here's going to be Teresa. Teresa, you're unfortunately going to be a rectangle today. All right. All right. So how do I? Because that's your slide. That's your slide. Okay. So how do I draw Brad's force? Teresa, how do I draw Brad's force? If it says 30 degrees to the horizontal, what do you think that means? Go ahead.
On the east and west, it's 3 degrees off.
Yeah. So this is going to be the horizontal, sort of going this way. And Brad's going to be pulling like that. Okay? And there's B for Brad.
But how do you know, like, which direction?
It doesn't, unless, since I didn't say it doesn't really matter. I did one is 30, one is negative 20, so compared to the horizontal. You could have done this and that, and I'd give you still full marks for it. Okay? And this is 60 newtons. Okay? All right, Teresa, with that knowledge, where would negative 20 degrees to horizontal be? Yeah, right? Again, this is the horizontal. We're saying positive's up, negative will be down. Okay? So this is going to be Callan. Okay. So Callan is a vector like this, and Brad has a vector like this. Okay, now this is the part for the non-physics students that's going to blow your mind. If I am adding two vectors, because Brad is pulling in one direction, Callan is pulling in another direction, you have to add the vectors. How are they going to be added? I can't just add those like that. What do I have to do? Go ahead. Yeah, well, you can do vector components if you want to. I'm going to use trig in this case. You don't have to. You can use vector components if you want to. Okay, but how can, you could use vector components, yes. What do I have to do though to the diagram though? I definitely have to rearrange it, okay? Because the vectors have to be added to the tail. So I'm going to make a triangle out of this. I'm going to use Brad here at the top. There's a 60. Then I'm going to add Callan, which is in blue, down like this, which is also 60. And this is my resultant, is going to go sort of like this. All right, so let's try and get some angles in here. I know that's going to be 30, and I know this is going to be 20. Let's try and rearrange him.
Wait, what does the 30 do in the bottom?
Yeah, I'm using Z pattern though. Okay, so this, you're exactly right. This part's 30. Right, so I'm just going to get that. Okay. If you don't like the Z pattern, you could also do this sort of thing. Right, 30 and 60 is 90. So this would be 60 and that's 30 then. Okay, if I want to solve for R, where am I at here now? Austin agrees to that you. What do I need to do to solve for R, please?
Find the interior angle between the 30 and the 20.
Good, what is that going to be, please?
130.
Thank you. Now, how'd you get, Chris, so quick to 130 degrees for that
Because
topic?
since like the horizontal line is a line and there's 30 and 20, I did 180 minus 50.
Good. Okay. Now I'm going to solve for the magnitude of R. Michael, I know you're still writing here. Do you want to pass on this and I'll come back to you?
No, wait, what's the question?
I want to solve for the magnitude of R. I want to solve that bottom line. How do I do that?
Something adds up to 180 or something.
No, not quite, not quite. Go ahead.
So you could use
Cosine line. Now, again, somebody said, I want to use components, go for it. Like, components are great. Okay, you can also use cosine line. Go ahead. Yeah, no problem. Sorry, what we said is here, an entire line is going to be 180, right? Okay, so if this is 30 and that's 20, we just did, you know what I mean, 180 minus 50. Sorry about that. Yeah.
Why can't you just like add the two angles together? Like the side like the
Oh, well, because the thing is, the vectors aren't added like this, right? The vectors have to be added, this and this is the way they have to be added, right? So that's why you can't just directly look at that. Okay, so I said cosine law. Luke, can you recite cosine law from memory? Magnitude of R is equal to, hold on a second. Magnitude of R is equal to?
Oh, I don't really know the cosine law. It's not locked in yet.
Do you just want the intermediate?
We taught you in grade 9, 10, and 11.
You did.
Shame on that person.
Actually, no, grade 11 was split, so that's my
Yeah, okay.
Like, do you want this, like, just...
Yeah, it's gonna be 60 squared.
Oh, okay, 60 squared plus 60 squared minus 2 times 60 times 60 equals 130. And then it should be R squared equals 2,571.93.
We'll start over 2.
571.
Yeah.
0.93. And then if you square root that, it becomes 50.71.
Is that right? It should be a lot bigger than that. 108.75 times more sense. 108.75?
Yeah.
108.76. 108. Okay, now how I knew Chris that I think he did the negative, we got mixed up on that. But think if somebody's pulling 60 this way, somebody's pulling 60 this way, and it looks like I have the numbers, I'd be closer to 120, right? Like almost 120. We got it or no?
No. So.
Okay, let's do angle now. Now this angle is going to be tricky here. I'm going to erase this one. Which angle, and I'm going to pick on you. Which angle will I be solving, the left or the right? Hey, how are you? Good.
You.
Yes.
No, it's technically subtracting, even if I add these two, because if you just put this in one,
I don't come close to it. I think go to yeah. Are you going to be on one side?
oh, you're right. Okay, that makes sense.
Yeah, they only want me in the 2 days a week now, so. Alright, but you can decide if it's Monday, Wednesday, Saturday, or something else. Figure out whatever day you want me in.
Like, we're actually gonna relax.
Yeah, okay, I got it.
Yeah.
I know, I was too.
Alright, sorry about that. Okay, just start minutes and nurse, by the way. Second one, you need to go and make sure you know this. What angle? Shh, listen up, please. Nicole B squared. This is Spider-Man's tree. So Hannah, is it going to be the left? You'll get to skip your turn when we come to you. Is it going to be this one or this one we find and why? Oh, I want you to know for your test. This is why I picked on you. Somebody help her, please. Okay. Colin's going to be the left or the right and why?
The left one, because that's where it starts.
The vector's starting on the left-hand side, right? So because the vector's starting on the left-hand side, that's what the direction is based on. Okay. So I'm going to solve for theta right here. What is, hold on a sec, please. What is my answer going to be? How am I going to get the overall heading? It's going to be what? Go ahead.
It's going to be 30 degrees. Like for the...
Not quite. We don't know it's necessarily. Bailey, go ahead.
So from the north, and it will be 60.
Yeah.
Oh.
So what we're going to say is here, theta, hold on a sec, please. Theta is going to be 60, whoops. Heading is going to be 60 plus theta. Okay, in order to get my theta, I'll do this quick so I'll get to the next example. Sine theta over 60 equals sine 130 over 108.8. Did anyone get an angle for that one? Teresa, did you get that?
I'm just like wondering why it's not 30.
Okay, because 30, if you look at the triangle, we're going to use this angle for 60. 30 is from here to this, so 30 is. Okay, but we don't know, because we don't know what this little, tiny little smidge here is, right?
What's the little blue dot?
That's going, because that was going to, the question, because the original question said this line was west 30 degrees north, or whatever you want, east 30 degrees north, like 30 degrees from here. So we use that to get to this 30 up the top. Yeah, go ahead.
I got 25.
25.0.
Well, there were 7 zeros.
Okay. Therefore, R equals 108.8 newtons. We'll say 85 degrees from vertical. Right? Because horizontal is going this way, vertical is that. You can also say 5 degrees positive from horizontal. All right, you guys ready to do an inclined plane problem? Or we'll do tension first.
Did you do R as the variable because we're finding the result?
Result is yes. All right, let's do tension first, then we'll get to 2 inclined plane problems, and we're done, hopefully. Yeah. Vertical. Okay, so this is example 2. We're going to say a large balloon is tethered to the top of a building. By 2 guy wires attached 20 meters apart. If the buoyant force in the balloon is 850 newtons. And the two wires make angles of 58 degrees and 66 degrees with the horizontal. Find the tension in each wire. Okay, this question or something like it will be on your test. Tension questions and on your exam and everything else. Tension questions are a fundamental vector question. Now, as you guys are writing, I'm just going to talk about this balloon. Okay, the balloon is trying to float upwards. What is stopping it? Well, the two wires are stopping it. So what I want to know is how much force is in each wire. I could ask you on a test, I could say Spider-Man is trying to hold together, you know, using his two webs to hold together or something. If his webs can only handle 400 newtons worth of tension, will one of his webs break? Like, you know what I mean? It could go any way. That sort of question could go on there too, but the idea is there's something floating up, there's going to be two wires connected to it, holding it into place. If it's being held into place, one of my physics students, what is the net force?
If it's not moving, it's 0.
0, okay? Meaning that what we're going to try and do for this one is we're going to try and make sure that the force going up, 850, the two wires will have a force 850 going downwards, okay, to balance it out. Yeah?
Isn't there still like the gravity force?
This one we're assuming there's not. It's just we're going to say, the only force we're going to say for this one is 850 up, okay? If I would have said something like the balloon weighs 2,000, you know, whatever, then I would have put in there. We'll just assume the force I'm giving here. I'm trying not to make this super difficult here. I just want to get the idea of zero net force. All right, Nicole, I'd like you to help me if you could with this. Whoops, wrong way. Try this way. I'd like you to help me with this diagram if you could. So where's the balloon going to be? What's the force of the balloon going to be?
Force?
Yeah.
150 newtons.
Okay.
Like, are you asking what the diagram will
Yeah,
look like?
yeah.
It should be like one vertical line up,
Yeah, one vertical
and
line.
then two triangles on either side.
Good. So this is going to be 850 newtons. That's going to be the balloon. Okay, two triangles on either side. Now this is the way we draw these. Luke, if it says 58, we'll do the first one on the left, the second one on the right. If it says 58 degrees to the horizontal, what does that mean, please?
Off of
Off this way. And I'll call T1 tension 1. All right, Derek, what's the second tension wire going to look like, please?
It's except for the 66 degrees.
Yeah. Now we're going to make the assumption here, and I don't know if I should or not, but they're going to be on opposite sides, okay? And that's going to be T2.
Wait, why
Sorry?
is it like an opposite? Because isn't like the balloon tethered by the two wires?
Yes.
Yeah. And then the middle line is kind of where the tension is.
Yes, what we're saying is together they're going to add up. They're going to add up. So here, think of it this way. So in order for there to be a net force of 0, the balloon is pushing upwards at 650. What we're saying is T1 plus T2 has to equal 850 down. Okay? The reason for that is because it's pushing up at 850, the balloon is, the two wires tension together has to equal 850 down.
So technically when you draw it, you kind of like put those, it would be like that, but the arrows would go into that.
Yeah, but you're going to draw it like this, but I'm going to, when I add these two together, so I'm going to redraw it one more time, if I mean like that. I'm going to draw T1, I'm going to draw T2, and then I'm gonna add them together, and it's gonna be 850 newtons down. Okay? Because the reason, everyone see why it has to be 850 down for the non-physics people? No, the reason for that is, Haley and everyone else, right, the idea is the balloon's pushing up, it's not going anywhere, which means that the two wires are pulling it down. Okay? Can I borrow your pencil for a sec? Hold on to it. So hold on to your pencil, please. I'm pulling this upwards, so he feels it pulling downwards, so it's not going anyplace. Well, you gotta think of that, right? The balloon's pushing up, so the two wires are going downwards. Are you okay on the logic for that? Yeah, go ahead.
Does the triangle have to look like that?
The other way it could look is you could have done the red one first, and then the blue one like this. But it has to be these two ones added together. So whether it's, and then equals something going downward. So this is going to be T1, and this is 58 degrees. And this is, what is this, 66? And this is T2. Okay, now the nice thing about physics and vectors is this is just a grade 10 math question now. What am I actually looking to find? Who am I up to? What am I actually looking to find here right now?
Just what are we looking for right now?
Yeah, like what's the just in general for this question? What are we looking for?
I'm looking for the force on each wire.
Yeah, so we're looking for the value of T1 and the value of T2. Okay, Matt, back to grade 10. So I'm looking for X and Y on that triangle. What do I need? What else should I put in this triangle in order to help solve it? Some of the missing angles would be a good idea. I'm not sure it makes it a little bit bigger if I can. Nope. Nope. Okay, I can't make it bigger. Okay, so Matt, what's some missing angle you can put in there?
The bottom corner, I think would be 34.
24? Okay, so the reason he got that was, again, it's 66 straight across, right? And then making a 90-degree angle and it goes like that. All right.
But do you know it's a 90?
Oh, yes, you do know it's a 90, because we said it's 66 degrees. We said it this way.
Oh, right.
66 from the horizontal and this is straight down, so you do know that's 90. Okay, so I didn't mean to say it like that, Bailey. I respect you greatly, Bailey. Just so you know.
Okay.
All right, Nathan, what else do I know? What other angles do I know?
You could do another right angle.
Yeah, good. So this is going to be?
That's 34.
32, I think. That's supposed to be 58.
Oh, that's 58?
Yeah.
Uh,
Sorry, that's why I tried to make it bigger. Okay, Hannah, since I passed on you, I'm going to Cecilia. Cecilia, there's one other angle I can put in there. What's it going to be, please? 58, you said? Okay. I'm going to call this big thing theta. What is the size of that big green angle? I trust you, 124. So everyone see that, right? Well, so you see what I did there, right? We have 58 on the top. We have 66 on the bottom, but together it's going to be 124. All right, James, back to grade 10 when you started your beard. How do you solve for T1, please? Because we have enough opposites now, right? We can do sine off on it, okay? So I'm going to say T1, which will be in blue, all over sine 24 equals 850 over sine 124. So T1 equals 850 times sine 24 all over sine 124. All right. Alistair, were you able to get an answer to that one, please? 417 point. I'd like everyone to confirm that they got that same answer. Take a second to calculate it out yourself, please. We're all sort of good? All right, Emma, can you be brave and tell me, please, how to solve for T2? very same thing, okay? This question, once you know how to do it, is very nice. Again, it's the once you know how to do it part that's the trick, but. And this is why, although not everyone likes drawing diagrams, once you get the diagram drawn, it just, like, I wasn't kidding. In grade 10, if you were in my class, I would have given you this question. I would have given you the diagram, and I said solve from the two sides, right? But it's just getting to that point that's a trick here, okay? Was anyone able to get the answer? Go ahead.
Oh, no, I haven't gotten the answer, but I was just wondering, because before when we would find angle, it would be sine on top.
Right.
Is it okay if we just do it for this one?
Yeah, that's fine, so you got to cross them all. I just do the unknown on the top class, it just makes it easier.
Okay.
Haley, were you able to get an answer to each? Yes, please? Oh, no problem. Go ahead, please.
543.21.
I apologize, this is fast and furious, I know. This is fast and furious, I know. Yes?
So does it matter that they're 20 meters apart?
No, that is useless information, and I stole that one from Mr. Lacy. I don't know, I had Mr. Lacy in grade 9. Any of you guys had Mr. Lacy in grade 9? Grade 10. So he used to love to do that. He would say, a fire truck pulls up to a station. The fire truck was red. No information, but he throws stuff like that in there, right? The fire truck's name, the dog's name was Bow Wow, you know what I mean? Like they throw extra information, stuff like that. I'm going to pause in the video here, and then we'll continue on. Oh,